raining yet, so that's good. I'd like to introduce today's speaker. Gary Woodall is going to be talking to you. Oh, turn that. Yeah. And also, this month's sponsors for the program is John Bird and Graham Sweeney, so thank you to them as well. Now Gary he's a retired meteorologist. He was a meteorologist for 34 years. So if you have any weather questions as well, I'm sure he knows all the answers on that one too. Like, how is Monday going to be? So
the answer is, I don't know.
Well, today he's going to be telling us all sorts of things about the eclipse, and make sure to also take a look. He's also a photographer, and so we have on display his photography up front. So take a look at that as we go through the museum as well. It's really cool pieces. He goes out at nighttime. In fact, I think tonight he's going out at 2 in the morning or something.
Hopefully so, if the sky's clear. Yeah.
So they're fascinating pieces as well. So without further, and if anybody can silence your phones, and I'll turn it over to Gary.
All right. Thank you, Susan, and good afternoon, everybody. Good to see so many folks here. And yeah, as Susan said, I was a meteorologist with the National Weather Service for 34 years, but was born and grew up in Central Florida, not far from Cape Canaveral. So I always had kind of an interest in space and the space program. And I fancy myself an amateur astronomer and astrophotographer as well. So most of what we're going to talk about here this afternoon is the eclipse, the big event coming up on Monday. A few slides at the end I put in just to talk a little bit about the astrophotography, since we do have the display here. A little bit of the process and procedure that goes into that. So let's hope everything works. Yes, okay. So starting out talking about the sun, which is really kind of the star of the show, you might say, for Monday. Actually, several layers that make up the sun. The outermost layer is called the corona, and that's actually the sun's atmosphere. We typically cannot see the corona except during times of a total eclipse. So it's really important not only for just the visual aspect, but the scientific researchers really focus on these eclipses because it's a good opportunity for them to observe and study and document the corona as well. And the corona is pretty warm. It's about 2 million degrees or so. All right, come on, there we go. The lower atmosphere is called the chromosphere, and that is the layer where some of the flares and the prominences and the eruptions off the sun's surface are visible. Come on. There we go. Oh. Then the photosphere is actually the visible layer. If you see the astronomers that take pictures of the sun with their special telescopes, they're actually taking pictures of the photosphere. That's the visible surface that we see. And then the internal, the core, the sun is really just a giant nuclear reactor. And the central part of that reactor is the core of the sun, and it's a balmy 28 million degrees or so. Pretty warm. All right. So what happens when we have a solar eclipse? Well, basically all it is the moon, the earth, and the sun basically line up, and the moon's shadow is cast upon the earth. So as this occurs, as we're watching from Earth, come on, the moon actually appears to block out the sun, which sounds a little bit strange if you think about how small the moon is and how enormous the sun is, but we'll touch on that here in just a minute. In fact, we'll touch on it right now. So the sun is actually about 400 times the size of the moon. Again, much larger than the moon. But the sun is also about 400 times further away from the earth than the moon is. So when you scale it all out, basically, up in our sky, the moon and the sun look like they're about the same size. And so that's how the moon is able to, that little puny moon that we have is able to completely block out the massive sun that is up there in our sky. So as the solar eclipse unfolds, there are a couple of different parts of the moon shadow. The first, the penumbra, is sort of the partial shadow of the moon, and that is where people would experience a partial solar eclipse. Then the umbra, the actual center of the moon shadow, where the moon will completely block out the sun, that would be the area or the path where the total eclipse would occur. So we can have different types of solar eclipses. We can have what's called a partial eclipse, in which the sun and the moon are not perfectly lined up as the moon passes in front of the sun. So the moon winds up only blocking a part of the sun, and we wind up with a crescent sun like we see here. And last October, when we had the annular eclipse that I'll talk about here on the next slide, up in our area, we had the partial eclipse from that, and so again, a crescent sun, very similar to what we see here. Now, when an annular eclipse occurs, the moon passes completely in front of the sun. But when the moon orbits the Earth, it's not a perfectly circular orbit. It's actually a little bit egg-shaped, the moon's orbit is. So it's a little bit further away from the Earth at times. It's a little bit closer to the Earth at times. So if we have the moon pass in front of the sun, but it's when the moon is further away, it won't completely block the sun's disk, and we wind up with an annular eclipse like we see here. It's oftentimes nicknamed the Ring of Fire, and again, especially down in southwest and south central Texas, this is what they experienced October of last year. And then finally, we have the total eclipse, in which the moon completely blocks out the sun, moves completely and perfectly in front of the sun, but the moon is closer to the Earth, so the moon is able to completely block out the photosphere and let us see the corona and those more outer features of the sun's atmosphere. And the corona is visible during the eclipse, and also along the very edge of that dark disk, the dark shadow of the moon, we may be able to see some of the flares and the prominences, eruptions from off the surface of the sun. Those may be visible as well. You'll see that in some of the pictures and in a couple of video clips that I've got to show a little bit later on. So again, it's a really interesting thing for the astronomers and the solar scientists when we have a total eclipse like this. And as we get close to totality, and this is why I'm really hoping we have good skies on Monday, there's some really interesting effects that happen in pretty rapid sequence as we get towards the total portion of the eclipse. Oops. The first of these is called the diamond ring effect, and you'll hear this mentioned a few times on the video when we show it. This is basically the last little bit of the sun peeking around the edge of the moon. Again, we see this just before and just after totality, and it's the last of the direct sunlight that's peeking around the edge of the moon. At this time, the corona is starting to become faintly visible, and corona, by the way, has its origins in Latin, the Latin word for crown, and it does kind of look like a crown radiating out from the center of that dark disk. So the corona becomes faintly visible. We have the last bright part of the sun, and again, the effect looks like a giant diamond ring up in the sky. Bailey's beads, another effect that we might see as we get close to totality. These are actually named for a British astronomer, Francis Bailey. They are seen in total eclipses between the diamond ring and totality, may be seen in some of the annular eclipses as well as the moon passes along the edge of the sun's disk. Basically what we're looking at here, of course the moon is not a perfectly smooth surface. It's got mountains and valleys and craters, edges of craters and all that. And this is actually sunlight that's shining in between the mountains and shining through the valleys on the edge of the moon. And again, this may be visible very briefly before we get to totality. And then when we reach totality, of course, we have the corona visible. And also, we'll be able to see some structures in the corona as well. There's one of the prominences. There's another one over there. Again, these eruptions and ejections of gas from off the surface of the sun. They're there all the time, though those aren't specific to the eclipse or special to the eclipse. They're there all the time, constantly occurring. But during the solar eclipse, the total eclipse, they're much easier to see. So why don't we have an eclipse every month? I mean, we orbit the sun and the moon orbits the earth, so why don't we have an eclipse every month? You know, things should line up, you would think. Well, actually it doesn't happen because the moon's orbit is tilted about 5 degrees from the Earth's orbit. So sometimes when the moon is between the Earth and the sun, it may be a little bit high or it may be a little bit low. Its shadow is not in position to fall directly on the Earth. Again, it's only when we are perfectly lined up but with the sun, the moon, and the Earth that we will actually have an eclipse. Again, it's a pretty rare occasion, in fact, for those three bodies to perfectly line up for an eclipse. So total eclipses over North America are rare events. Again, total eclipses are rare to begin with. Total eclipses over North America are even more rare. This is a look at all of the eclipses that occurred in the 20th century, in the 1900s, over North America. Not a whole lot of, a dozen maybe, during the entire century. And you notice the different shapes and the different orientations to the tracks. That's because everything lined up at different places in our orbit around the sun, in the moon's orbit around us, different places, different times that those alignments occurred. So there's the 20th century eclipses. Here's the 21st century eclipses. 2017, the last total eclipse from Oregon down across the Central Plains to the southeast U.S. There's our event for next week, and starting out in the Pacific Ocean, going across Mexico, the south central to the northeastern U.S., northeastern Canada, and on out into the Atlantic. So again, April 8th is going to be the big day, the day of the eclipse, and the eclipse actually will begin, the alignment will first begin well out over the central Pacific Ocean. We'll track again across Mexico and across the central and eastern U.S. and end actually well out into the eastern Atlantic Ocean before the alignment finally breaks apart. Whoops. And again, while we are going to be one of the fortunate ones here in the path of totality, much of the eastern, about half of the country, is going to have at least 50 to 60% of the sun obscured as a result of the eclipse. So again, it's going to be a big event, not just for us, but for a good portion of the country as well. So in 2024, come on. Again, this will be the first total eclipse in the continental U.S. since 2017. It'll be the last one in the continental U.S. until 2044. That will be up in Montana and North Dakota area. And the next one that'll be somewhere close to us is not until 2045. That'll track across New Mexico, Oklahoma, Arkansas, and then down towards Florida. So again, it's going to be a while till we have one back in the immediate area. Our totality period will be about 4 minutes and 28 seconds. That's the greatest period of totality anywhere along the path, and that's pretty long by eclipse standards. A lot of eclipses may see the 2 to 2.5 minute range for totality. So this is going to be a fairly long duration event as far as eclipses are concerned. And again, as far as the U.S. is concerned, from southwest Texas up into the northeastern U.S., and then on out into the Canadian Maritimes. So here in Greenville, what are we going to see specifically? Well, the partial eclipse will start. The moon will first start to move across the sun's disk about 12:24 or so in the afternoon. We will start totality at 1:42 p.m. And depending on where you are in Greenville, it'll be somewhere around 4 minutes and 8 seconds to 4 minutes and 10 seconds of totality. So again, going to be a fairly long period of totality that we're going to have since we're pretty close to the center line. That blue line there is the center line of the path of totality. That's where the longest amount of totality would be. For comparison, I live over on the north side of McKinney, and there it's going to be about 3 minutes of totality that they wind up seeing. So we're actually in a little better position here as far as that's concerned. Then the moon will start to move off of the sun's disk and will completely be off by about 3:04. So about 2.5 hours, 2 hours and 40 minutes total, with that magical about 4 minutes and 8 seconds right there in the middle. Now, if any of you all are telescope operators and have those motorized tracking mounts, one thing to be aware of is the mount, the sun is going to be at vertical, as much overhead as it's going to be about 15 minutes before totality. So at that point, those of us that have telescopes and operate them are going to have to flip the telescope around so it can continue tracking through totality. So just one more thing we'll have to be on our toes on as we get close to that magic moment. Now, as far as the weather during the eclipse, there'll be some interesting things that we'll notice there as well. The biggest thing that we'll notice is a significant temperature drop, especially as we get past about 3/4 of the sun being covered. You'll start to notice a drop in the temperature. And from outside of the eclipse to totality, would not be surprised to see 10 to 15 degree drop in our temperatures. Basically, we're going to be going into dusk, and so we're going to be losing the sun's heat, and it will show up in the temperatures. In the partial eclipse areas, there'll be a drop as well, not as much as in totality, but folks in the partial eclipse area will notice a drop in temperatures as well. If we have any cumulus clouds, the little low puffy clouds, those will probably dissipate and decrease as we lose that heating and as the temperature drops as well. Now, this is going to be an amazing event to watch, but we need to watch it safely. So one thing that I will emphasize, I'll probably emphasize it about 5 times here in the next 5 minutes. Do not look directly at the partial eclipse with your naked eyes. Make sure that you have your glasses to do that. Even at 99% coverage, the sunlight is still too intense and it will damage your eyes. So need to use your approved eclipse glasses, approved either by NASA or NIST or ISO. And the places that sell the glasses, if they are approved glasses, they will mention that in their advertising, that they are approved and are good ones to use. Also, the American Astronomical Society has a list of retailers that are selling approved glasses as well. Of course, time is getting short as far as looking around for places to buy the glasses, but the list is there if you need to consult it. Again, even at 99%, the light is too intense for us to look at just with our uncovered eyes. Now, if it's getting close to the day, you got your glasses, but you look at your glasses and you see there's a little scratch or a little hole or a little bubble in them, swap them out, because again, just that little imperfection can be enough to let enough light and enough radiation through to really cause problems for your eyes. And any damage that occurs, excuse me, may not be immediate, but it can be permanent. And so again, we really need to be careful as we're watching the partial phases of the eclipse. Total eclipse, when we're in totality, yes, you can take the glasses off, take the special protection off of your camera lens and the like, but up until then, need to keep everything covered up, need to keep it protected. If you do have a camera and if you're planning on trying to photograph the eclipse, well, you'll need a special filter for your camera lens, but if you do that, you can just look at your camera screen or your smartphone screen. That's safer than looking directly up at the sun itself, of course. But again, we need to use a solar filter on our camera. I've got the filter already set up for my telescope and ready to go. Even if you've got just a smartphone, you'll need to have protection for your smartphone camera lens as well, because the light and the radiation that's coming in is probably going to be enough to fry the sensor of your camera, and then you're going to have a repair bill and all that inconvenience. So again, just make sure that your camera lens, your smartphone lens is protected as well. And an easy way to do that, you can get a little gizmo like the company here has to clip over your smartphone, or just get an extra set of glasses and use one of those lenses. You tape it or clip it somehow over the front of your smartphone, and that'll give it good protection as well. And again, look at the screen. Do not look at directly at the sun with your unprotected eyes during a partial eclipse twice. Now, some other things that you can do, especially if you've got young ones that are going to be joining you or visiting for the eclipse, one thing you can do is to make a pinhole projector. Take a piece of poster board or some heavy cardboard or construction paper, punch a little hole in it, maybe about the size of a pencil tip, and then hold that paper down at the ground. And you'll actually make a little projection of the sun and the eclipse on the ground. Another thing you can do is to crisscross your fingers in a waffle pattern like that, and then hold that down at the ground, and you'll actually see the little pattern of crescent suns formed by the holes in between your fingers along the ground. Or if there's a leafy tree nearby, especially if you've got a little wind and the leaves are blowing around, look on the ground underneath the tree. All the little holes between the leaves will make a whole pattern of the little crescent suns down across the ground. So something else that you can look for as the eclipse is unfolding. Again, the key, do not look directly at the sun during the partial eclipse if you don't have your glasses on. 3 times. What do we not look at during the partial eclipse? The sun. All right, excellent.
Not unless you have glasses on.
Yes, if you have, got to have your glasses on. So, again, our eclipse is going to be probably, well, come on, the most widely documented eclipse in history. Certainly has the potential to be. Some of the reports that I've seen, maybe as many as 7.4 million people traveling from across the country and across the world to the U.S. to see it. And one reason it's going to be so documented is over 32 million people just naturally live in the area of totality. It's unlike 2017, where Nashville was really the biggest city to be affected. This eclipse is going to cover, it's Austin, Dallas-Fort Worth, Little Rock, Columbus, Ohio, on up into the Northeast. So a lot of people naturally live in the area that's going to be covered. And we will see research, not only the photographers and just eclipse fans coming in, but researchers as well. Again, these total eclipses are really important times for the solar researchers to look at the corona, to study and document the corona and other features that are really only visible during a total eclipse. Up, back up, back up. Come on. Okay, this, if it plays, it did play earlier. There we go. A couple video clips from 2017. This first clip is near Beatrice, Nebraska.
Moment of totality here on the prairie. What are some of the things we should be looking for?
So if it clears, you should see
Notice
a
the cloud cover.
and that it looks like a pearly, hazy crown around the sun. And in fact, it's called a corona because that's Latin for crown. And then as it's going beautifully dark here, it's becoming twilight. You hear everyone going crazy here. You should be able to start seeing stars, and you can actually see 4 planets. This time you should see Jupiter, Mercury, Mars, and Venus all in this night sky during the day. So it's just an amazing, amazing experience. And if you can't see the corona, I do have a map of it here. This is a 3D print that was done for me, and it looks exactly, it's a predict of what the corona looks like today. So if it's cloudy, here's your corona.
Now, it looks like the moment of totality is upon us. Let's just let the guys at home have a few moments to take in the sights and sounds of the crowd as totality happens on the prairie.
And you can see the corona, and I may cry, but you can see the corona. So now you're seeing this wonderful hazy atmosphere. I don't need my glasses now, Vince, because we are in totality. And so this is the only time that it's safe to look. But right now you can see that hazy ring. That is the chromosphere. It is looking a little bit sort of reddish. And you just see all those red wisps are little prominences that are coming away from the sun. Unfortunately, we can't quite see the stars yet because of the clouds. But my goodness, you can see the corona, and that is an absolutely incredible, incredible sight.
You can see one of the prominences right there.
Well, other than the people hooting and hollering here, everything else has gone quiet. The animals think it's nighttime. There's this amazing sort of twilight view all around us. And just look at that corona. That is incredible. Absolutely incredible.
Yeah, that's amazing.
Yeah, and the moon is going to continue. We've got about 2 minutes, 35 seconds of this amazing view. And then here we come. Here comes the diamond ring. So it is glasses on again time. Glasses on. And here it comes. There's the diamond ring. That is the most spectacular sight.
That's amazing.
It's just incredible. And of course the diamond ring you see because the moon is not a totally smooth sphere. And so you're seeing little spots of light peeping out between the craters on the moon. And my goodness, I'm sorry.
This eclipse is actually
Now, if we get lucky and get clear skies, this is what we would look like. This was, again, 2017, Hopkinsville, Kentucky.
So we are at the point on the surface of the Earth where that time occurs.
Exactly. The shadow.
And they have the special solar filter over their camera here.
That's right. And it's just getting really dim, and we are just so close. It's incredible.
Yeah, this is amazing. We can't wait to break out in the darkness. We've got our glasses out. We've been looking up at it. You can see now on the screen our live telescope view. And this is just amazing. Everybody is really enjoying it. We've got people from all over Kentucky, people from all over the world have joined us here as this is Eclipseville, USA. And we are just a few minutes away from total totality. But before we get to that point, Renee, tell us, you're a planetary scientist and you specialize in the moon, a lunar scientist. How does the eclipse really speak to what you do?
Well, it is pretty cool to look up there, and when you're seeing that sun get dimmer and dimmer, it's because the moon is up there. And I like to tell everyone that you're really looking at the moon when you're watching a solar eclipse, and it's just getting dim, and it's starting to get a lot cooler too. It's incredible.
This is my first solar eclipse. Renee, have you ever experienced one?
This is my first total eclipse too. I've seen partial eclipses, but I've never had a chance to see totality before, and I'm just so excited.
It's amazing. The light is starting to fade as the moon steps in front of the sun here, and it's already just a really eerie feeling here, getting dark in the middle of the day. But we're really excited about it, and we're just a few seconds away. I've lost my counter, but I'm going to look back at the sun while I still have the opportunity. Wow, that is absolutely amazing. We're down to just a thin sliver of the sun. Renee, what do you think about this?
I can't believe it. It's just, it looks incredible, and it really is starting to get dim, and nobody even needs their sunglasses. Just your eclipse glasses, and you can see that beautiful crescent sun.
Wow, this is absolutely amazing.
We're just really looking forward to that for a chance. We got no clouds here in the sky, and you can see some airplanes up there, but that sun's just getting smaller and smaller.
Yeah, it's definitely a Hopkinsville, Kentucky Chamber of Commerce sponsored day here in Eclipseville. It's amazing how it's gotten so much cooler here since the sun started covering up, started being covered.
Yeah, it's nice to have a break from that hot southern sun.
Yeah, definitely. We've been sweating it out a couple days here in Hopkinsville getting ready for this.
We're getting really close now.
So what exactly are we looking at here, Renee?
Well, we're just about close to 100%. It just getting smaller and smaller, and it's getting dimmer and dimmer, and hopefully soon we'll have a chance to see those Bailey's beads and that diamond ring. That's when you can actually see the light shining through the moon's valleys. The moon's not a perfectly smooth sphere, it's got that rugged surface, and you can see those sun rays shining through those mountains and valleys and craters. Wow. It's looking like we're about 1 minute out now, and just getting smaller and smaller.
Wow, this is amazing.
The crowd's getting really excited too.
Hey guys, who like coincides with the solar eclipse? Wow, it's getting closer.
Wow. It's just getting really close to nighttime. It's incredible. It's like very dim.
Definitely it feels like dawn or dusk here in Hopkinsville right now as it's getting closer.
And you can see on our feed, there's that tiny, tiny little sliver left to go.
Still haven't used the solar filter.
Now. Wow. It's like dust. And you can see the pink color around the horizon. Oh, it's like a sunset. It's beautiful. It's going. It's going. Just that tiny, tiny last sliver. Oh my goodness.
And we are in total solar eclipse. This is absolutely breathtaking.
Yeah, you can see the corona, that beautiful white wispy crown coming out from the sun in all directions. And we can see airplanes, and I think I see Jupiter in the sky over there. I think I can see Jupiter.
Wow.
And I see other planets too, and stars.
I can only imagine in ancient times what this must have been like. Out of nowhere, I am covered in head to toe in goosebumps and continue to chill.
I know, I am too. I just can't believe we finally got a chance to see it. I mean, it's one thing to read about it, but it's another thing when you get to see it yourself with your own eyes.
Guys, we're going to take a break here in just a second. We're going to step back and fully enjoy this and hope you enjoy our feed on the telescope.
On Monday, next Monday, if we have good skies, we'll see the eclipsed sun. To the left, we'll be able to see Venus, and then a little bit further to the right will be Jupiter. And I don't know if it'll be visible to the naked eye, but in between the eclipsed sun and Jupiter will be comet 12P Pons Brooks. It'll be up there. I just don't know if we'll be able to see it or not. But there will be stars, and again, some of the brighter planets that will be visible during totality as well.
Is that the comet that has the two horns?
Yes. Mm-hmm. Yeah, the devil comet they refer to it as. Yes. Mm-hmm. All right, so summarizing as far as the eclipse goes. Again, this is going to be an amazing event. Regardless of the sky conditions on Monday, it is going to be an amazing event for us to witness and experience. Safely make your observations of the eclipse. And again, you'll probably notice the temperature drop as we get in closer towards totality. Enjoy the event. Again, this is going to be a terrific event to observe. And as far as the weather forecast goes, fingers crossed. Taking a look at the forecast, and again, since I am a meteorologist, I do try to keep up with those type things. There we go. It looks like we're going to have a weather system come through probably Saturday night or so, late Saturday night. What we want is for that system to slow down a little bit. If it could slow down by about 12 hours or so, that would be awesome. Because the slower that system exits, the longer it'll be before the clouds from the next system start to approach the area. So we might be able to get a little window there in between the two systems. Also, if the system on Saturday is a little stronger than it's currently forecast, that's going to pull down a little more dry air into the area. That's going to, again, make it a little more difficult for the cloud cover with the next system to make it into the area. So hope for a slower and stronger weather system Saturday night time frame. We'll cross our fingers for that. But again, regardless, as you saw in the video, Even if we have some clouds, we'll still be able to see parts of it at least, and so it's going to be an amazing event to experience and witness. So to wrap up, just a few slides about astrophotography, and these are the images that are out there that Susan had mentioned when we kind of kicked things off. Now, a lot of the targets that I take images of, like the galaxies, nebulae, which are the big gas and dust clouds that are out there in space, star clusters and the like, are pretty large features, but they're very faint. They are extremely faint. Most of them we cannot see when we're visually looking through a telescope. So when we hook the camera up to the telescope, we need to do very long exposure times to be able to capture these images. Total exposure time in hours as opposed to minutes or seconds. So we need a telescope. The telescope doesn't have to be special, but some of the equipment that goes with the scope and the camera are kind of specialized equipment as well. Then we need software to process the image data that I gather with the telescope and the camera. And basically what we're trying to avoid and get rid of are light pollution, which is becoming an increasing problem, and then just electronic noise within the camera and the computer and the gathering system itself. Those will lead to decreased quality of the images that we get. So this is actually what my setup looked like about a year ago. Of course, the big white telescope is the main imaging telescope, and then what looks like the little red thermos down here, that's actually my camera that I use. The little red and black telescope up here and the camera that's connected to it, this is called a guide scope. And the mount that I use, this mount that the telescope is on, it is motorized. It will basically have the telescope follow the same part of the sky for that several hours. That's how we're able to do those long exposure images. But the mount has gears and belts and stuff that leads to just a little bit of slop in the system. So what the guide scope does is that camera takes a picture about every half second of the stars and sends that data to the computer, which is the little red box here on the side of the telescope. The computer compares images, and if it sees that the stars have moved even just 1 pixel, it will actually send instructions to the mount and say, okay, speed up a little bit, okay, you're good, okay, come left a little bit, all right, it's good, okay, slow down a little bit. It's constantly sending instructions like that to the mount to make little minor adjustments as we're going through the exposure process. The black bands that are around the main scope and the guide scope are dew heaters, which are controlled by the little black box here. They just slightly heat up the area around the lenses to keep dew from forming on, because that will mess up the quality of the image as well, as you might guess. So that, again, about a year ago, was what my setup looked like. So here's kind of the process. Here we have a single 4-minute image of nebula SH2-86. That's impressive looking, isn't it? No. It's basically here.
West Texas sky.
More stars.
Okay, I'm just going to do this.
Okay, so yes, basically it looks awful. But what we can do, okay, I thought this was going to work. Oh. Okay, I'm going backwards now. Okay, go forward, please. Okay. What we can do, though, is take a bunch of these 4-minute exposures and use the software to stack those exposures together. The stack term goes back to the era of the glass plates that the old astronomers used to use when they would take images. And so we can stack the plates, and that gives us something like that. What the stacking will do is reduce the noise. It'll sort of cancel out the noise and bring out more of the nebula itself. So this gives us an image that's better, but it's still not very good. So what we need, because we still have some light pollution, you can see kind of over here. The stars are kind of big and bloated and overwhelming things, so we still have a little bit of work that we need to do. So we take the image and do post-processing with that image. Come on. So, whoops. There we go. So we use the software, post-processing, to reduce the light pollution, to kind of dial back the stars a little bit, enhance the contrast, and we get something that is finally somewhat presentable. Now, the pictures that you see from the Hubble telescope, from the James Webb telescope, they go through this same type of stacking and post-processing, just of course on a much larger, a much grander scale than us hobbyist level type folks would do. So summarizing, again, the astrophotography, many hours of camera time went into the images that are out here in the exhibit, and then many more hours of time went into the post-processing to remove the light pollution, remove the electronic noise, come up with the final versions that we see, either here or, again, looking at the Hubble or James Webb or the other images that are out there. It's a time-consuming hobby. It's a consuming hobby. Again, I may be heading out at 2:30 tomorrow morning to go do some more imaging, but really something that I've found fascinating, being able to combine the art from the photography with the science of what it is that I'm actually imaging out there, and has really been rewarding for me. And really, to me, just shows that there are beautiful works of art that have been created for us out there in the universe. Really, really beautiful things to see. Yes, sir?
I have a slightly different question. I recently read about a supercluster of galaxies.
Mm-hmm.
Could you tell us just how big that cluster is and how we figured it out?
As far as how they calculate distances and stuff, I know that they use frequency shifts and differences in the shifts of the light that's coming out from the galaxies and the like. To be honest, how they do it is a little bit above and beyond me, but yeah, there's a huge cluster of galaxies in the constellation Virgo, and I'm not sure if this is the particular one, but yeah, there's probably 100 or so galaxies, and you figure each galaxy is maybe 100 million stars on the average, and so again, just staggering the number that's out there. But yeah, there are, we have planets that orbit our sun orbits around in the galaxy. There are galaxies that orbit around each other, and it's just a larger and larger structures that we're finding out there, and just again, the distances are just absolutely staggering. And again, how the astronomers came up with all, they're a whole lot smarter than I am.
The only thing I remember, and I'm not sure I got the number right, but it was like several hundreds of thousands of light years across.
Yes. Mm-hmm. Mm-hmm.
Is that right?
Yes. Mm-hmm. Yeah, and a light year is the distance that light travels in a year. So it's somewhere in the hundreds of millions of miles, just to put that in perspective for you. So yeah, just staggering distances that we're talking about. Yes, yeah, 186,000 miles per second light travels. So figure that over an entire year. And then we're talking, again, hundreds of thousands. And actually the most distant object I've ever imaged in one of my scopes, it was a speck in the background, was a galaxy that was 101 million light years away. So that's just amazing, amazing distance. Yes, ma'am.
When you were talking about how you could look at that without hurting your eyes, my daughter was up here during that
Annular? Mm-hmm.
From Boston,
Mm-hmm.
and she got my big colander, faced it, and you could watch it do it on the sidewalk.
Yeah, that's kind of a bigger version of the crisscross with your fingers thing. Yeah, so you'd get a whole pattern of them then on the sidewalk. Very cool.
Certainly will
well, a piece of wire screen or a colander or something like that, yeah.
Stand under an oak tree.
Yes, yeah, and watch them all across the ground, yeah.
You mentioned the path that the eclipse is going to cover from someplace in the Pacific to someplace in the Atlantic. Roughly how many, what's the distance of that, do you know?
It would be probably, I'm kind of just looking and eyeballing it, I would guess probably about 4,000 to 5,000 miles that'll cover. Before then things just get out of line enough.
Right, I understand, that's what I was referring to, yeah.
Gary, when you take your, I didn't realize you were photographing different nebula, which is interesting. When you're doing that, are you taking your data, comparing it to NASA's, and just trying to glean some more insight out of things, or do you like to have also just a nice library of different celestial bodies?
Yeah, in my case, since I'm very much a hobbyist level with this, it's pretty much just the artistic beauty is what I'm capturing. And knowing that those things are out there. I do try to learn about the objects that I'm imaging, so I know a little bit of the science and the story behind what produced. Like, oh, this one, that's the remnants of where a star exploded, and this one is where maybe some stars are forming type thing. But yeah, what I'm doing would be so far below what the research grade people are doing. It's strictly, again, just the visual and capturing the beautiful objects that are out there.
Question. I'm so surprised in so many of the images, yours and then some of these others you see from, the web and all those. The colors. There are so many vibrant colors, it seems like, in the gases or whatever they are. What are those caused by?
The gas, yeah, the colors in the gases that you see can be caused by one of a couple of different things. Some of the nebula are what are called emission nebula, and they are gases. Usually hydrogen or oxygen are the main gases that are out there. And what will happen is the gases will be hit by radiation, usually from a nearby star, and ionized. That is, a little electron will get knocked off of some of the atoms, and then when it rejoins, the atom will let out a little energy, and some of that energy will be in the form of light. And what gas it is will determine what color it is. Hydrogen will tend to glow red when it's ionized. Oxygen will tend to be kind of a tealy blue-green color when it's ionized. Sulfur is also kind of a dark red. There are other things that are out there, other gases that are out there, but hydrogen and oxygen are the two most plentiful that you'll see. Now there's another type of nebula called a reflection nebula, which is basically just a dust cloud that's out there. And in that case, it will usually pick up the color off of whatever star is nearby, reflecting light off of it. So a lot of them will be bluish colored, kind of a bright blue color. Some of them, though, like around the star Antares, which is a red giant star, so it gives off a very reddish light, the dust will have kind of a goldy orange color to it. So it will just pick up the color of whatever star nearby is lighting it up. Then there are what are called dark nebulae, which are dust clouds, but they are so thick that they block out the light from behind them, completely block out the light. And so they will appear silhouetted dark against a background of stars or other gases or whatnot.
Gary, talk about how you sometimes produce an image using a different color, like the Hubble color spectrum or color processing.
Okay, yeah, a lot of the images that are out here are natural color, where hydrogen is red and oxygen is blue-green and whatnot. But the researchers will oftentimes use false color palettes. They will say assign the hydrogen a gold color, a golden brown color, and then assign the oxygen and the dust a bright blue color. And they do that, the researchers do that to more easily tell the difference of what's causing what as far as the nebula. So, okay, yes, this one does definitely have a good amount of oxygen in it, for example. Like the supernova remnants tend to have a lot more oxygen in them than just the regular nebula do. And so by using the false colored palettes, again, assigning the colors based on the gas versus instead of just the natural colors like we would see if we were looking at them. They can pick out some of those things more easily, and it makes for, visually makes for some really cool and neat looking images as well. But a lot of that again was developed by the researchers so they could more definitively say what was making up that feature that they were looking at, that they were trying to study. Yes, ma'am.
Our grandson is studying meteorology at
Awesome.
Oklahoma University, and he's got an internship this summer in Lubbock with the National Weather Service.
Oh, fantastic.
Well, all we know is the weatherman on TV.
Mm-hmm.
But could you tell us some of the things that you do in meteorology?
Sure, and he will like Justin Weaver. I worked at the office in Lubbock from 1990 to 93, and Justin was an intern when I was out there. He's now the head of the office out there. Great guy. He's gonna love working with him. But yeah, the National Weather Service, we prepare the public forecast that a lot of times the TV meteorologists will use. Maybe use as is. They may adjust it and massage it a little bit for the day-to-day forecast. National Weather Service also are the ones that prepare the tornado and severe thunderstorm and flash flood watches and warnings. So when the TV people break in and say the National Weather Service has issued a severe thunderstorm warning for Denton County like we had last night, that's the meteorologists at the National Weather Service that are making those decisions. NWS will also prepare the specialized forecast for the airports across the area, DFW, Love Field, for example, with the parameters that are specific for the pilots to know if it's safe to take off or land at that particular airport. NWS will also prepare fire weather forecasts with parameters that are specific for the firefighting community, so that if there are any prescribed burns, you know, when they do the management of the brush and the undergrowth and all out in the forest areas, they'll know what conditions to expect. Or if a wildfire were to break out, they would know what the weather conditions were going to be, so they would know how that might affect the fire and how they could best attack it. And that was, of course, front and center with the horrible fires up in the Panhandle here a short time ago. The NWS will also, this was my primary job with the NWS, work with TV meteorologists, the emergency management and emergency response officials at the cities and counties and the area that office covers, the storm spotters, to make sure that they're all getting our information in a way that they can use it and in a timely manner, and making sure that we have that two-way communication set up so that they know when we issue something, we know when one of their spotters has a report or if they experience any damage or anything. So it's a lot of behind the scenes work. Like I say, a lot of people, you know, when people found out I was a meteorologist, oh, what station do you work for? so it is kind of behind the scenes, but it's a lot of really important work that the NWS meteorologists do.
I was just going to say, that is an impressive piece of capital expense you have there. I was thinking telescope or camera, but that just far exceeds. Is there a national group or a global group that you get together with and you all discuss these things? Because you're at a level that is certainly not, it exceeds amateur, it seems to me.
Well, actually, my stuff, believe it or not, is pretty low end. There's a group based in Dallas, the Texas Astronomical Society, and they actually have a photography subgroup, and they talk about general astronomy stuff as well. But they're based in Dallas, and they have monthly meetings and the like, so I usually try to join up with them. When I was in Memphis, where I kind of got started with all this, there was a Memphis Astronomical Society, kind of the same thing. But yeah, some of the higher end folks have setups. You could get a pretty good car for the cost of their setup. So yeah, I'm still really pretty ground floor as far as that goes. But yeah, as far as the astrophotography goes, you can put as little or as much money into it as you want and are able to.
How much is a rig like yours?
Oh, let's see. Yeah, let's see. The big telescope was about $500, I think. The camera was about another 600 or so. The guide scope setup, probably about 400 or so. The mount I got used for about $900. So
you put it all together.
Yeah, yeah. Because I started out with just my camera, a camera and a tripod, and took pictures and kind of got good with that. And then got a little, it's called a star tracker. It's just a mount that I could put my camera on that would follow the stars. And okay, so I got kind of better with that. So then I got the guiding system, so okay, now I can guide a little bit longer. Okay, now I need a bigger telescope, so we get that. Okay, now I need a bigger mount to carry the telescope, so we get that. But it wasn't all at once. It was kind of a gradual step-up process as I went along.
You have a sympathetic wife then?
We have a deal. We have a deal.
Now, all the equipment, it costs that much, but what about the editing software? That's got to probably be a lot more expensive.
The software that I use is, well, two pieces of software that I use. The one to do the stacking and like the initial analysis and noise removal and all was, I think, $275. And then for the final stuff, the contrast and whatnot, I use Photoshop. And starting out, I only use Photoshop because people have developed little special like macros and tools and stuff designed for astronomy stuff. So I got the little package for that again as I was starting out. And a lot of the software, some of the basic software, like to do the stacking and whatnot, is actually free. One great thing about the astronomy community is it's a very giving community, and a lot of people have developed stuff that is free for new people to be able to use. The software that I'm using now, people can write modules for, people do write modules for a different way to reduce the stars or to add better color into the stars after the processing, and they'll just upload them for free for anybody to grab and bring into the program. So it is a pretty giving group as well. Yes, sir.
Do you think the chickens are going to get confused?
Yes.
When it gets dark?
Yes. The street lights will come on, and yeah, probably the chickens and all the animals will figure, okay, well, it's nighttime, and so they'll start kind of bedding down and whatnot. And 4 minutes later, they'll, wow, that's a quick night. Yeah, we will see probably the animals and the wildlife acting as though it's getting dusk and towards the end of the day.
Go to chicken.
We hear the coyotes sound, we're in trouble.
We may. Yes, sir.
You're retired. How much of your time do you spend on your hobby versus time you spend at work?
Well, of course, obviously when I was working, work had to come first, and so I would just kind of fit in wherever I could to get an evening, go out with a telescope and whatnot. While I'm retired, I'll say I think I'm probably more busy now than I am when I was working. But if I want to get up at 2:30 in the morning and go out and do an image, well, okay, I'll just sleep a little bit the next day. I don't have to get up and go to work and whatnot. So the big limiting factor now is the clouds, the weather. Because finding, you'd think, well, gosh, you just go out whenever you want, but you'd be surprised how relatively few, I need a moonless or near moonless night because the bright moon will wash out a lot of these faint features that I'm trying to get. So I need moonless, I need clear skies, I need not too much wind, below about 10 miles an hour or so. And those days are really not as easy to come by as you would think. So that's usually the big challenge. And then of course when we do have cloudy periods, I can go through and learn new techniques for using my software and processing, go back and reprocess an old image that I did before and practice the new techniques and stuff. So yeah, there is still a good amount of time that's spent in the hobby. Not as much outside under the stars as I would like, but I'm hoping this next about 2-3 nights is going to be pretty good for me.
Why does the wind speed make a difference when you're doing photography?
since I'm doing the long exposures, 3, 4, 5 minute exposures, if the wind is blowing enough, it'll vibrate the telescope just a little bit.
That's right.
And while I've got the guiding, and that can help with some of it, sometimes it may be just a little bit too much for even the guiding to be able to fix. So.
You don't have portable, whatever, I can't remember right now, the term for.
Yeah, I don't have an observatory.
Yeah, that's what I think, portable observatory.
I know one of my neighbors, who's another astrophotographer, he's actually built little light screens and wind screens that he uses, but I don't have those yet. I'm still kind of at the mercy of
Have you tried the Fort Davis location for light pollution? And
I absolutely want to go out there, and I've not been out to the McDonald Observatory, so I absolutely want to do that. And yes, I will definitely haul my gear out there when we. Well, I hope that we have a great day on Monday. It will be a great day. I hope it's a great day weather-wise. Thank you all.
Thank you so much. Really enjoyed that, and I'm looking forward to Monday. It'll be fun. I don't remember the last one. I was a kid, and all I remember is making the box. That's it. And going outside, and the teacher yelling at us to not look up. And let's see. This weekend, as part of the activities, we are having Space Day on Saturday from 10 to 1. We will be open specials all day Monday. We will also be open special on Sunday as well, all day. And next month's speaker is going to be Rod Mizell. He's going to be talking about the work they're doing in the Philippines. And have a great afternoon. Make sure to take a look at the exhibit on the way out.
This video has been brought to you by GEUS. GEUS is your community-owned provider for electric, internet, cable TV, and true local programming.